Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about how to optimize subqueries in Postgres by understanding the Postgres planner better. This is a blog post by Laurenz Albe on the Cybertech blog. And in this post, Laurenz describes the different ways of how subqueries are used in a query and what that means for optimization decision the planner makes. And what I liked about this post was that Laurenz found a good set of terms of how to describe how a subquery is used in the query and what that means for performance. To start with, what we mean by subquery is a portion of a query where you put something in parentheses and you have an outer query, and then in that inner query, you're doing a subselect on a particular table that might reference data from outside of that subselect. The most important aspect of subqueries is that there's what you could call correlated subqueries and uncorrelated subqueries. An uncorrelated subquery is a query that does not reference anything else from the outside, versus a correlated subquery is when the query that's inside that subselect is referencing something from the outside. We're selecting from a table A, and then in the target list of that query for table A, we're also selecting from a table B, and we're referencing a column of the original table A. And so you obviously first have to get the data from A to then be able to do the lookup on a table B. That's a correlated subquery. If you don't do any reference to the outside, then that's an uncorrelated subquery. This is a really important difference because when uncorrelated subqueries are encountered by the Postgres planner, then Postgres will not pull this up into the overall query plan. It will actually treat it separately from the main query. And so what you will see in your explain plan is what's called an init plan. That's essentially an initial plan that's done independently of the rest of the query that then, for example, could be used to do some other lookups, but that subquery itself does not require the result set from the main query. Uncorrelated subqueries are almost never a performance problem. And the reason is because they're usually just executed once. And so this article deals mostly with correlated subqueries. What Laurenz describes here is the difference between a scalar subquery and a tabular subquery. A scalar subquery is when the query returns just a single data point, a single value. That's a scalar subquery. For example, when we say where and we're matching the number of elements, so we're saying select count star from something in a subquery, then that's going to be a single value that's being returned, a single row being returned, and that's a scalar subquery. On the other hand, what's called a tabular subquery would be when you are referencing something that returns multiple rows. For example, you could use a tabular subquery in a from list where you're returning multiple rows. Common table expressions, CTEs, are a good example of this. And also in lists or exists or not exists expressions are also good examples of that. And different from what we said earlier about uncorrelated subqueries, scalar correlated subqueries are actually performance problems. As Laurenz states here, you should usually avoid them if you can. The reason for that is pretty simple. If you have a scalar subquery, they have to be implemented as a nested loop because of the way how Postgres executes it. For each of the rows that it's encountering, it will have to evaluate that correlated scalar subquery. And so that means that if you are having a lot of results from an earlier table scan, you will have to run your scalar subquery for each of those results. And so that quickly becomes very slow. One technique that Laurenz describes here is to focus on rewriting these scalar subqueries explicitly into a join. When you don't have it in a subselect, but you actually write it as a join, Postgres will be able to use other join techniques besides nested loops. In this example here, we are actually able to have a left join, and that left join is semantically equivalent and actually gives you a similar result. There's some edge cases where you have to watch out for, which is why the planner doesn't do that automatically. But if you are rewriting your query, this is usually a safe transformation to do. In the second case that Laurenz showed earlier, you can also do this with a group by clause and having, and this will also let Postgres choose a better join strategy. An interesting case is when we're looking at in and not in. There's this variant of in where you're saying this column in, and then you have a list of values that you're getting from that subquery. Postgres will generally be able to rewrite this in a way where it is going to be more efficient. And so you can see here in this case, the condition that you were joining on was being pulled into a subselect. If you write not in, then Postgres will not be able to do this type of pull up. it is actually important if you are finding yourself to use not in to instead use not exists, because that will perform better. And last but not least, Laurenz mentions an interesting aspect. A lot of this article is about avoiding the forced nested loop that a correlated subquery will usually produce. However, sometimes you want to make sure Postgres uses a nested loop. And of course, you could use techniques like using pg_hint_plan to force the optimizer to always do nested loop join. But one of the things you can do is you can force a nested loop join by writing a lateral cross join, because that will always be done as a nested loop by Postgres today, at least. And one of the things where I find that useful is when you want to make sure you get a parameterized index scan. So you want to make sure that you are able to use an index on the lookup on that second table you're joining with. Then it is actually very useful to be able to force a nested loop. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.